Hello, Algebra 1 students. In this video, we're going to talk about proportions and similar figures. In the last video, we solved proportions. So by the end of this video, you should be able to find a missing length of a triangle in similar figures and use similar figures when measuring indirectly. Now let's talk about some vocabulary. Similar figures. When I say similar, I am talking about the same shape, but they have a different size. If you look at these two triangles, they are similar, but they've been scaled differently. Triangle ABC, we use the triangle symbol to compare these two, is similar to triangle FGH. The difference is one is bigger. Okay, we get the angle, this is what that means, and then in between here we get the squiggly line and the equal sign. That means they're congruent, so they're going to be the same shape and same size. And when we're doing proportionates, it's important for you to know that we're talking about in this case AB will be proportionate to FG. That just means that they share the same ratio. Okay, and the same thing with AC and FH, and then the last one would be BC and GH. Okay, so you have two triangles here. They're saying that triangle ABC is similar to triangle DEF, but what is DE, the side DE? We can figure that out simply by just putting in a variable here instead of calling it DE. Okay, since we know that they're similar, this means that the side DE is going to be proportionate to AB. Okay, again, when they're similar, they have the same shape, just different sizes. So we can set this proportion up, and we're just going to put this as 10 over x. And then the other information we know is the side EF and BC are also proportionate. So if we could set that ratio up to say that we have 16 over 12. Now all you got to do is do the cross multiplication, cross products. Because I like doing my variables on the left side, I'm going to go left or bottom up. So x times 16 is simply 16x equals, and we're going to go 10 times 12. So this you can write out with a dot if you want, or you can write it out with parentheses. It doesn't matter, whatever you're comfortable doing. Just don't get confused by that dot and think it's a decimal. So now this becomes 16x equals 120 divided out by 16. Okay, and then x will be roughly 7.5. You can use your calculator. So this side here is 7.5. Now they've given more information. If you notice here, they have right here 18. Okay, so technically we could find the side of this other side, AC, now that we know all these other sides. So we could set up the same ratio just like we did before, if you were wondering. Okay, interpreting a scale drawing. This is not something that you'd have to do on a daily basis when you're out on the road. Your parents, or if you're driving already, you would use Google Maps or GPS. However, as an Algebra 1 student, you need to know how did GPS get their information. So this is exactly how it happens. You have to have a scale drawing, which is basically a scale factor in your map, and then you would just need a ruler. So what is the actual distance from Jacksonville to Orlando? Use the ruler to measure the distance. So what we do know is the map scale equals for 1 inch is 110 miles. Okay. The other information we know is that, and all you need to do is line up the ruler with the dot. Like here's Jacksonville, right? And then Orlando's right here, and you just have to count in. There's actually four 4 lines, which is equivalent to 1.25 inches, 1/4 of an inch. The next thing you would have to do is you could just set up your proportion. Take your map scale, which we know, which is 1 over 110. So 1 inch, 110 miles. That will equal in proportion to the map distance over the actual distance. So our map distance is 1.25 inches. And we can figure out how far apart Jacksonville and Orlando are in miles by representing it by x. And we're going to do the cross products. I'm going to do the x first. So I'm going to do 1 times x, which is simply x, equals, and then we'll do 110 times 1.25. So then use your calculator. X equals 110 times 1.25, which is 137.5 miles. I don't know if that is the true information or not. You could probably go on maps and verify that. So the prior example had a picture. What if you're given something that's just a word problem? As long as you're reading it correctly, you can get this done and no problem. So on a map, 1 inch equals 20 miles. So there's the proportion they're giving us. So 1 inch is represented as 20 miles. If 2 cities are 9 inches apart on the map, how far apart are they? So we're saying that they used a ruler for us. They measured it out to be 9 inches. But how many miles does that mean in the real world? So go ahead and set up our proportion, our ratio, and then cross multiply. So again, I'm going to take my x first. So 1 times x is just x, equals 20 times 9, which is 180. So I'll just do, we'll do 20 times 9. So x is 180 miles. This is an example of a real-world problem. A sculptor is designing her new triangular masterpiece in her scale drawing, which is something she probably does on paper. The shortest side of the triangular piece is made to measure 9 centimeters. Okay, so I'm going to draw this out for you. You can do this as well if you need that visual. It's helpful. Okay, and then the longest side of the drawing measures 17 centimeters. Now, if you're not sure which one to use as your longest side, always remember that when I'm just going to assume this is a right triangle, the longest side will always be across from your right triangle. We call that the hypotenuse. Okay, so now the longest side of the actual triangle piece, the one that she's going to sculpt, must be 17 meters, or sorry, 19.7 meters long. So let's make that as a picture here. So we're going to make this 19.7 meters. So it's huge. How long would the shortest side of the piece be? So we don't know what the shortest sides will be. Okay, since these, we're going to assume they're both similar, right? Then our proportion is going to be set up that the shortest side will go over x. So we're going to set up that proportion ratio of 9 over x equals, and then the longest sides, we have 17 over 19.7. Okay, so this is going to be set up like this, 17 over 19.7. I probably should put my units, but I'm just, for lack of time, I'm just going to leave it out. So then let's cross multiply. X times 17 is 17x equals, and then again, you're going to take 9 multiplied by 19.7. So that comes out to, let's do a little calculator. I'm going to use my calculator. 9 times 19.7, that's 177. 0.3. Now you're going to divide that out by 17 on both sides. Okay, so x equals, once you divide that out, I'm going to use my calculator again, we get 10.4. Now in Math Excel, it'll probably ask you to round to the nearest tenth. All right, well, that was it for this video. I hope you all have a wonderful day.